Section 2.3 Quadratic equations in one variable. This section, we are going to look at the definition of a quadratic equation in one variable, the way to solve quadratic equations by factoring, by perfect square method, by completing the square method, by using the quadratic formula, and then we look at the applications of quadratic equations at the end. For the definition, a quadratic equation in one variable or a second-degree equation is an equation that can be transformed into the form of ax squared plus bx plus c equals 0. X is the unknown order variable where a, b, and c are real numbers and a cannot be 0. Otherwise, it's not called a second-degree equation. To solve a quadratic equation, first we are going to write the equation so that 0 appears by itself on one side. Then we factor or write it as a product of the two factors. The last step, we're going to apply the zero factor property to solve the equation. The zero product property is in the form of, we have the product of the two quantity. For example, x minus a times x minus b equals 0. We apply the zero factor property by letting x minus a equals 0, x minus b equals 0, and then give us x equals a for one solution, x equals b for another solution. Let's take a look at the example. We are going to solve the following quadratic equations by factoring. First, on one side is 0, which part A already in that form. And then this one is in the case of ay squared minus 14y. Like that. So going to be a times y squared plus b times y plus c equals 0, where a equals 1, b equals negative 14, and c equals 40. Since a is 1, so when you factor, you just look at the value c, which is 40, as is the product of the two numbers. They both have the same sign because the product is 40, but the sum going to be the same as the value b, which is negative 14. So the two numbers that we can think of would be 10 and 4. But since the sum is negative and both have to have the same sign because the product is positive 40. So we're going to have negative 10 and negative 4 as those two numbers. Now back to the main part of the problem. That means y squared minus 14y plus 40 can be factored as y minus 10 times y minus 4 equals 0. And then use the zero factor property to make y minus 10 equals 0 or y minus 4 equals 0. Solve for y. We have y equals 10 as the first solution and y equals 4 as the second solution. For example B, we have 33x plus 7x squared equals 10. This quadratic equation has the other side non-zero. We are going to rewrite it by leaving the other side as 0. So we're going to subtract both sides by 10 and write as the order of the degree in the declining order. We have 7x squared plus 33x minus 10 equals 0 as the form of ax squared plus bx plus c equals 0. We can see that a is 7, b is 33, and c is negative 10. Since the a or the leading coefficient is not 1, we are going to factor by starting with multiplying the value a and c, which is 7 multiplied by negative 10, results as negative 70. And then we look at two numbers that the product is negative 70. But the sum of these two numbers is the same as the value b, which is 33. Since the product is negative sign, that means one of them must be negative. Then we put plus sign here and minus sign here. We look for two numbers that the product is 70, but the product is negative 70, but the sum is positive 33. Since the product is negative, but the sum is positive, therefore the greater quantity will have the same sign as the result of the sum. So we have a pair as number 35 and the number negative 2, that the product is negative 70, but the sum is positive 33. That takes us back to the main part of the problem, that 7x squared plus the number 33x is broken down as 35x minus 2x and then minus 10 equals 0. And then we're going to use the grouping technique or the grouping method to factor the left-hand side expression by group the first two terms, 7x squared plus 35x together, and then the last two terms together in one quantity. And next we look for the greatest common factor of each group. The first one, we have 7 as a common factor of the 7 and 35, x as the lowest number of the x and x squared. So 7x is the greatest common factor of the first group. The remaining factor will be x plus 5. The second group, as we are going to look for the common factor or the common quantity in the later steps, so we look for the greatest common factor as negative 2. So factor negative 2 out. The remaining factor of the first term gonna be positive x, and then the second term gonna be positive 5, which matching with the quantity that we got from the first group after we factored. So this case, we factor the quantity x plus 5 from those two terms, and then the remaining factor of each term gonna be 7x minus 2 equals 0. So 7x come here and negative 2 comes there. And then we can see that we have the product of the two factors. At this step, we're going to apply the zero factor property. By having the x plus 5 equals 0 as one factor, and the other one, 7x minus 2 equals 0. So for x for each one, the first will give us x equals negative 5. That is one solution. The next one, we add 2 both sides and then divided by 7. So then x equals 2 over 7 as another solution for this problem.